Welcome back, everyone, and we are in week 2 and we're progressing into the class, and we're going to talk a little bit about the generative manufacturing and engineering, and we've talked about it in the classes you've taken in the past, and how this movement is really making its impact in our manufacturing. Now, how did we manufacture before? And you're looking at some of that. That is my big background, was in machining, conventional machining and engineering. And you're looking here is a vertical milling machine, and that was more or less what we started with, is a conventional machine like this. There's all other kinds, but this is one that we'll look at. And timeline, as we advance further, we got into CNC. Now, this machine over here, you manually had to use that to make the part. And you'd have a blueprint and, of course, your tolerances and things of that, and your dimensions, and you built that part. Well, time went along and we come into the age of computers, and we got the computer numerical control machine, and both of these machines are used heavily today. Don't get me wrong, this CNC and conventional machining, it's still around. It's the heaviest used in manufacturing, okay? So don't get that confused. But the CNC came around. Instead of using manual methods, you programmed a computer, and you were able to generate your code, put it in there, and it would cut the material out to size using the CNC machine. And what is the difference back then and the advantages that we have today with additive? Well, additive manufacturing, if you all saw, it adds material. Now, this conventional machining that we use is more of a subtractive. You take a part blank, and you take that big raw material, and you cut it to the exact size. And you can kind of see this here. This is on a manual vertical mill, just like this one. And they're actually making this part. So you're taking a large piece of material and you're cutting it, and there's waste in that, okay? Well, in additive manufacturing, we're seeing less waste. We're seeing less waste, and we're seeing the ability to make more complex shapes a lot easier than the conventional methods of the past. Now, like I said, I've been working this field for years, and back in the 90s, I worked for a company, and we got a 3D printer. And I remember they brought it in and unboxed it, and it was close to $30,000, and that was a lot of money in the 90s. Still a lot of money today. But I got to use that 3D printer, and we had CNC machines there too, and it was so neat because I could just take and program it, and it would develop that part, without having to do different operations as you would on a conventional machine. It could do it all. You added the correct support on it, it would do everything that you need it to do. But the only thing we used it for was prototype, because then the accuracy wasn't near as good as it is today. The speed, the efficiency wasn't near as good as it was today. And you didn't have all the materials that you have today. There's so many materials in additive that you can choose from. But in this, you're able to do more of things like this in the generative design in additive manufacturing, as opposed to this. Now, this is what we would have done conventionally. What's the difference as you kind of see this evolve down through here? What's the difference between this and this? Let me tell you, the one thing that's common between them is they both had the same structural integrity. That means they both can withstand the same amounts of pressures. They're designed like that. That's where we're going to right now in this class. We're going to start looking at why components fail and start looking at the stress and the ability for these components to withstand certain pressures. So that's amazing, isn't it? This right here, well, this design here is equivalent to this as far as its ability to withstand pressures or whatever the forces that's going to be on this component. They're able to withstand. And look at this one. It probably takes a third less material as this one. But in the conventional side of things, this one's so much easier to make. Now, if I had to make this one on a conventional machine or a CNC type machine, it can be done, but it's going to take a few operations to do it. It's not just going to take, I put it in there, set the part in there, and hit go, and it's going to do it. I'm going to have, some different axis machines, and even that, I'm probably going to have to do some other operations to it. I'm going to have to take that part out and maybe make a jig for it and put it back in to be able to continue and finish it up. So it would be a lot harder to make this on conventional machines as it is this one. And that's how we have advanced in time. So let's take a look at another thing here. And this is something very similar to that. Here is the conventional way that we would have made it and still making it today. But this is what we can make, and it'll provide exactly enough structural integrity to do the same as this. And look how much less material it took to be able to do the same thing. This one's a lot heavier, a lot more material, but for the purpose of it, this right here does the exact same thing. So that's where we're getting to in this class, and we're trying to get you to think like that, is why make something this big and large as you learned last time? Because the larger the material, the product is, the part, it costs more to make because, you're having to take each gram and it's worth so much money and time that goes into that. When you can come over here and you can build something like this that takes a lot less material, a lot less time, and it gives you the same ability. So that's where we're getting to in this class, and we're going to talk a little bit later in another video about the structural analysis of things and some basic components and the failure modes, why things fail. We're going to get into that in our next little video. So if you guys have any questions, this is where we're moving toward, okay, in this class. So it's going to be fun. You'll enjoy it, and we'll see you at the next video.